Find the sum to n terms of the following Arithmetico-Geometric series. Let us begin. So here we have a series which is given by 1 added to 2x added to 3x squared added to 4x cubed and so on. Now, in order to find out the sum of this series, we need to find out its nth term. But how do we find out the nth term? Because this is neither an arithmetic series nor a geometric series, but it's a composition of both of the two. So what we'll do, we're going to separate the arithmetic sequence from the geometric sequence first. Let's do one thing. Let's take the constant term. So starting with the first term, if we take 1 followed by 2, 3 and 4, so these terms are going to be in arithmetic progression, where the first term a, that's 1, and the common difference d, that's going to be equals to 1. Then the nth term of the sequence, which has the formula a plus n minus 1 times the common difference d. So substituting a and d with the respective value gives us the nth term as equals to n. And we can also pull out the geometric terms from this given sequence, the original series. So here we'll consider the first term to be 1, followed by x. Then we have x squared and x cubed and so on. So these terms are going to be in geometric progression. The reasoning is that here the first term is a and the common ratio denoted by r, that's going to be x. And now that we have the first term and the common ratio, then the nth term of the geometric progression, where it's given by a r raised to the power of n minus 1. Substituting the values, we get x raised to the power of n minus 1. Now that we have the nth term of the arithmetic progression and the nth term of the geometric progression, we can combine them to get the nth term of the Arithmetico-Geometric series. All we have to do is take the nth term of the arithmetic progression, which is n, and to it we are going to multiply the nth term of the geometric progression, which is x raised to the power of n minus 1. Now this is going to be the nth term of the Arithmetico-Geometric series. What we can do, we can verify this. So let's say if we substitute n value with 3, then a3, that's going to be equals to, we have 3 multiplied to x raised to the power of 3 minus 1. So that gives us 3x squared, and this is indeed the third term of the series. Now that we have the nth term of the series, let's try to find out the sum to n term. So here we're going to suppose that Sn represents the sum to n term. We have the first term as 1 added to 2x, then we have 3x squared, then this goes on all the way up to the nth term given by n multiplied to x raised to the power of n minus 1. Now here what we'll do, we're also going to consider the previous term. Now the previous term, what we'll do, we only have, that's a very simple task to find out the previous term. We're going to replace the n value with n minus 1. Once we do that, we are going to get the previous term. So in place of n, we have n minus 1. And to it, we are multiplying x raised to the power of n minus 1. So when we replace n with n minus 1, we get n minus 2. Okay, so this is going to be the sum to n term. Now here, we obtained that the common ratio of the geometric progression came out to be x. So what we'll do, we're going to multiply throughout with x. On the left hand side, we have x times Sn. This is going to be equals to, we'll start with the first term. The first term of Sn, that's 1. When we multiply with x, we get x. So we have x. To it, we are going to add the second term. The second term of Sn, that's 2x. When multiplied with x, that gives us 2x squared. So this keeps on going until we reach the second last term. So n minus 1 times x raised to the power of n minus 2. When multiplied with x, so that's going to give us n minus 1 multiplied to x raised to the power of n minus 1. And then we have the last term. So that's n times x raised to the power of n. So what we'll do, we'll perform a subtraction here. So let's perform the subtraction. So Sn minus x times Sn, this is going to be equals to 1 added to, so 2x minus x, that's going to be x, added to 3x squared minus 2x squared, so that's x squared, added to, so this goes on. Then we have n times x raised to the power of n minus 1. From here, we're going to subtract n minus 1 times x raised to the power of n minus, because they both have the same coefficient, x raised to the power of n minus 1. So that's simply going to give us x raised to the power of n minus 1. And then we have the last term of xsn. So that is simply negative n multiplied to x raised to the power of n. Okay. Now on the left hand side, we have 1 minus x multiplied to Sn. This is going to be equals to, we're going to keep the first term and the last term intact. So we have negative n times x raised to the power of n. Now, if we look at this particular sum, this is a geometric series. Here, the first term that's equals to x, the common ratio r, that's going to be x as well. And here, there are n minus 1 terms present. There are not n terms, but n minus 1 number of terms. So let's try to understand quickly why that is the case. Now, when we consider the sum as n, we excluded the first term and we considered the second term all the way up to the last term. So this contains n minus 1 number of terms. Then coming to x times Sn. So here we started out with the first term and went all the way up to the second last term. So we excluded the last term, that leaves us with n minus 1 term. Now, after performing the subtraction of n minus 1 terms from another n minus 1 terms, we'll be left with n minus 1 number of terms. Now, we have a standard formula for calculating the sum to n terms of a geometric series. So that's given by a multiplied to 1 minus r raised to the power of the number of terms divided by 1 minus the common ratio r. Let's use this formula. So here, our first term, that's x. So x will get multiplied to 1 minus the common ratio x raised to the power of the total number of terms. So since that's n minus 1, so we have x raised to the power of n minus 1 whole divided by 1 minus the common ratio. So that's x. Now we're going to divide throughout with 1 minus x. So Sn is going to be 1 divided by 1 minus x. Added to, we have x multiplied to 1 minus x raised to the power of n minus 1 whole divided by, we have 1 minus x whole squared minus n times x raised to the power of n divided by 1 minus x. So this is going to be the final sum of the given Arithmetico-Geometric series.